Thank you for joining us for part 2 of our Material Science Heat Treatment Lab. Again, my name is Ryan Trembath.
And my name is James Simpson. And this time, the materials that we're going to need are fairly similar. You'll need a bobby pin, a cup of water, long-handled needle nose pliers, a heat-resistant glove, and some way of heating your bobby pin to approximately 1200 degrees. In this case, we're using a furnace. This is because we're going to be looking at the difference that temperature causes in the quenching process. Originally, in our first part of the experiment, we were looking at a phase known as austenite that we were heating to. This is because the propane torch that we were using had a flame temperature of approximately 3000 degrees. Accounting for cooling, we can assume that the temperature of the metal was between 2000 and 2500 degrees when we quenched it. Austenite, when quenched, produces a hard but brittle material known as martensite.
Well, now we're going to pose the question, what if the metal is not heated into the 2000 degree range? What if the temperature is only brought up to about 1200 degrees Fahrenheit? We've set up the lab for you to go out and experiment for yourself, and then we'll come back and explain the results. Now we're going to go ahead and show you what our results were. First, we put on our safety glasses, grab our heat-resistant glove, open our refractory furnace, which we use to heat the bobby pin up to 1200 degrees. Going to remove it, quench it. Now, as you can see, when I pull the two ends of the bobby pin apart, it no longer fractures as it did when it was heated with the propane torch, but rather bends and is more ductile than before. This is because, as you can see on the iron-carbon phase diagram, we heated it into a lower phase known as ferrite. Cooling from this phase does not produce the same martensite that was formed from the austenite phase. This allows the metal to remain ductile and bend rather than brittle and fracture. You should have seen similar results in your lab, and we thank you again for watching the videos and following along with us.